Hello and welcome to SudoKanard. Here is a Skyscrapers Sudoku puzzle that I created a long time ago. It was one of the first times I created a puzzle without using those useful tools provided by F-puzzles and such. No, I did create it on F-puzzles, but F-puzzles doesn't support the skyscraper constraint, so I had to do most of the logic by myself, all the logic by myself. Let's be clear about that. And that was a very nice experience at the time. Well, let's get on to the puzzle. So it was worth 80 points, and in my opinion, it should have been worth more than that because it's really difficult. And I'm really not sure I'll be able to do a convincing solve with this video. So where do we start? Well, you see that with this 7, those 6 cells can't contain a 9, and with this 3, those 2 cells can't contain a 9, so there's a 9 here to begin with. Now this 7 clue acts like a length 7 thermometer, so there are 2 degrees of freedom, namely this is at most 8, this is at most 7, at most 6, 5, 4, 3, but this is at least 1, so 1 or 2, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, 8. And if you dislike this extensive notation for candidates, I can't blame you. That's a bit tiring to do that, but in this case it's very useful because of this. And well, what I'm saying this is basically how I started constructing this puzzle. So what did I say? So this 8 clue, we have to see that this digit will be hidden, because if this digit were seen, it would mean that those digits here are less than 6, and that would make 7 digits less than or equal to 6, and that's not possible. So this digit is hidden, which means that all other digits are seen. So 1, 2, and 3 are seen at the beginning, 8 and 9 are seen at the end, and 7 is here, and 7 hides this building. And now this is 5 or 4, and this is 5 or 6. So that's for a beginning, and then this 8 removes 8 from this cell, so this can't be 7 anymore, this can't be 6, this can't be 5, can't be 4, can't be 3. And on this row, 8 is somewhere here, but to fulfill this 3 clue, 8 is here. And this is now any digit between 1 and 7, so this is not something we will find right now. This column now contains a 4, 5 pair, so this is 6. And this row, on this row, we know that 9 can't be here because of the 5, and 9 can't be here because of the 4, so 9 is here. So that's a start. And then this 5 clue acts like a length 5 thermometer. So this digit must be between this one and the 9. And you see that it can only be 8. And this is now an increasing sequence here. And the interesting part here is that this is an increasing sequence here. And 8 is not there. So 8 can't be here either. So 8 must be there, and to fulfill this 4 clue, 8 has to be here. That's the only place you can put 8 here. Now 8 has to appear somewhere here. It won't be at the beginning. It won't be here because of this 8, so it's here. And this is now increasing, and this here is increasing. You see that 7 is not here. So 7 can only be here on this row. And the remaining digits are digits from 1 to 5. So this only has a degree of freedom. 1, 2, 2, 3, 3, 4, 4, 5. And it puts a 4, 5 pair here, and we get a 1, 2, 3 triple here. And actually this 1, 2, 3 triple means that in this column 1, 2, 3 can only be here and there. So this is 1 or 2, this is 2 or 3. And the remaining digits are 4, 5, 6, 7. Well, obviously, when solving this on paper, I wouldn't pencil mark extensively all of this. We need to put 8 and 9 somewhere here, but here 8 wouldn't work because we would see at most 5 buildings. So 8 and 9 are here. And this is also 4, 5, 6, or 7. I pencil mark it extensively, but that's really not a good idea. So where should we look next? Perhaps digit 9. Digit 9 is not here. Because of this 3, 9 is not here. It's not here because of the 7, so 9 is somewhere here. It's not here, so we get a 9 somewhere here. And by Sudoku, 9 is not here, so 9 is here. And you can see that this is an increasing sequence to satisfy this 6. And we see that 9 must be somewhere here. That's correct. Where is the next place to look? So this is an increasing sequence of digits between 1 and 6, so there's not much to say about that, I think. We can see that this digit is bigger than this one. Not much to say either. Oh, except that one of them must be a 7, so 7 is here. It's bigger than that to satisfy this 3. So there must be a 6 and a 5 somewhere there. I don't think that's interesting. Actually, I will just color the clues that can't bring any new information. So this is fulfilled, this is fulfilled, and I think that's it. I think I've colored all the cells that can't provide any new information. So where else should we look now? Well, most probably this 7. This 7. So it means that 2 digits are hidden, and 3 is one of them. So only one other digit is hidden. And 9 will obviously be somewhere there, and 8 also, but 8 will be somewhere here. Oops, sorry about that. And what else can I do? I shouldn't do too much by memory. 9 is somewhere up there, 8 is somewhere there. And I think there's something about 9. Yes, 9 can't be here because then it would hide 2 buildings and that would make 3 hidden buildings, so that doesn't work. So there's a 9 here, and that's an 8-9 pair. So with those 9s and those 9s, we see that there's a 9 here. And this digit is bigger than this one. And there's something else about this. The odd thing about this is that this is impossible. So why is that impossible? Well, if you do that, then 3 and 8 are hidden. So the other digits are in an increasing sequence. So that's a 1, that's a 2, that's a 4. And you see that if you do that, then a 3 has to repeat here. So that's probably not necessary to solve the puzzle, but that was definitely in my intended solution. So 8 and 9 are in this order. I get an 8 here and a 9 there. So where else should we look? So 7 would make sense here. 7 would not make sense here, because if I put a 7 here, then 3 digits here are hidden. So that's never 7. 7 here would work. 7 here would definitely work as well. So knowing that only one digit is hidden, I think this can only be 1 or 2. And so the reason for that is if you try to make this a 4, then 1 and 2 will be hidden. And we already know that 3 is hidden, that's 3 hidden buildings. So that's not possible. And that's interesting because we get a 1-2 pair here, so neither of those digits is here. And in this row, that 1 and 2 must go there. So this is now between 3 and 7. And we know that 1 is not here. So knowing that those are ascending digits, 1 being not here, can't be here either. So 1 can only be here in this box. So it removes 1 from those cells and puts a 1 here. And with this one and this one, we get a 1 here, which makes this a 2. And we now know that the second hidden digit in this row is a 1. So the 2 hidden digits are 1 and 3, meaning that all other digits, all other buildings, 4, 5, 6, 7 will be seen. So 4 is either here or there. So it means that this is either 1 or 4. If this is 1, then 4, 5, 6, 7 are seen in this order. Otherwise, that's a 4 and 1 is somewhere else. So if this is 1, then this has to be 4, and if this is 4, then this has to be 1 or 5. 1 won't be here, so this will be a building that is seen. It can't be a 4, so it's 5 or 6. This is either 1 or a bigger building, so it can't be 4 or 5, and 4 is somewhere here. And this is either 7 or 1. This 8 and this 8, they put an 8 somewhere here, but because of the 3, 8 is here, which puts a 9 there, so that's a 9, and an 8 there. Now, what about this column? So this 7 now is not here, so on this row 7 has to be here. On this column 1 has to be here. There must be a 1 somewhere here. So 1 is hidden. And this again is interesting considering this 5 clue, because this digit will be hidden and this one will be hidden, meaning that in these 5 cells we already have 2 hidden buildings, and we know that to satisfy this 5 we must see the other 3 buildings. So this building, and the third building here must be seen. And this is at most 6. So the second seen building will be at most 5. And the first seen building will be at most 4. So this is 3 or 4. There is a 4 or 5 somewhere here. And the third building that we see is 5 or 6. Knowing that 7 must be somewhere here, that's not interesting. But we get a 5, 6 pair here. So this is 4, this is 3, and this here is 5 or 6. We get a 5, 6 pair in this column. So this is 4, this is 3, this is 2, and this is 5. Perhaps I could have had this 5 much earlier and didn't pay attention. Now this must be 2 or 3. Oh, and 1 can't be here because of the 3 clue here. So that's a 1. And this is the intermediate building between this one and this one. So this is 4 or 5. There must be a 7 somewhere here, but this would break the 3 clue. 7 can't be here, so that's a 7. 2 has to be here. So now this 3 is fulfilled, that is fulfilled as well. And I think that's it for the moment. Here, oh, this one here puts a 4 here. That's not a 4. This 4 makes this a 4. So that's a 5, that's a 6, and that's a 3. That's correct. This 5 now puts, this 4 puts a 5 here, that's a 6, that's a 5. No 5 here, so that's a 5, that's a 1, that's a 7, that's a 6. No 6 here. This 5 makes this a 6. This is a 3-4 pair, and we get a 5 at the bottom. This is a 6-7 pair. Right, so let's have a look at the clues. So this 5 is fulfilled, this 3 is fulfilled, this 7 is fulfilled now with only 1 and 3 hidden. This 3 is fulfilled. This 2 is fulfilled, and this 6 will be fulfilled in a moment as I enter the remaining digits in ascending order, and 5 will be the final disambiguator. So we get 2, 3, and 6 here. That's a 5, and that's a 4. 7 on this row can only be here. This is only 2 or 4. And that's the important part here. 6, 8, and 9 are seen, so this digit must be bigger than this one. Oh, sorry, this 2 makes this a 4. So that's 3, 4, 3 and 2, 2 and 3. Right. Actually, this is 5, this is 6, so this 4 is not a disambiguator. The end is just plain Sudoku. I color this clue for completion. So this is a 1-2 pair, so that's 1, that's 2. This is a 5-4 pair, so this is 5, this is 4. This is 7, this is 4, this is 6, this is 7. This is now... What did I do? What did I do wrong? That doesn't work. Where did I blunder? Ah. Alright, I just had a look at the solution, and the place I blundered was around here. Oh, that's it, I think. Yes, that's 7, that's 4, that's 7, that's 6, and that's 6, that's 3. Alright, so sorry about this mishap. So the essential logic was really... Well, there was a lot to do. There was a lot to do, but it was mainly about considering what cells are hidden. And I'm prepared to bet that on some steps there were easier arguments than what I say. Actually, this was the intended logic between this puzzle, and I really think it was worth more than 80 points, more like 90, maybe even 100 points in my opinion. But, well, you know, the people who make the rating, the point rating, they are very, very good solvers. So they may have found something easier than what I've done. So that's all I have to say about it. So thanks for watching this video, and see you soon on SudoKanard.